In this video, I want to look at converting between rectangular coordinates and polar coordinates and kind of going both ways with them. The thing to remember is very often when things are presented to you in polar coordinates, that's probably because that's the easiest way to find the areas or find the derivatives, find the slope, whatever, or graph the shape. But sometimes you do want to switch back and forth, and you do want to know, okay, well, what is, rectangular coordinates mean I know what it is in terms of x and y, and sometimes that's important to know. So I'm going to start by graphing the point 3 and 5 pi over 3. So 5 pi over 3 is in here, out 3 units is right there, okay? So here's what I want to know, okay? I want to know what is the x and what is the y that gets me to that point. Now, here's what I know. I know what the angle is, right? It's negative pi over 3 or 5 pi or pi over 3, whatever, however you want to think about it. And I know the length of the hypotenuse of my triangle is 3. Now, thinking about some trig here, if I want to know what x is, okay, that's the adjacent side. So adjacent, and I know the hypotenuse. I'm talking about cosine. So the cosine of my angle, I'm just going to write theta for now, must be equal to adjacent over hypotenuse. Well, that must mean that x is equal to 3 multiplied by the cosine of the angle. Now, what's really neat is all you need to do is say, well, the angle was 5 pi over 3. This is going to get us the x coordinate. So, of course, going back, the cosine of 5 pi over 3 is 1/2. So it's going to be 3 multiplied by 1/2. Remember your trig rules. So the x coordinate is 3/2. Okay? So a similar thing happens with the y coordinate, except, of course, this time we're dealing with sine, because it's the opposite. So I'll substitute that angle in. And the sine of 5 pi over 3 is negative square root of 3 over 2. So this is going to be negative 3 root 3 over 2. And that is your rectangular coordinate. It's at 3/2 to the right and down 3 square roots of 3 over 2 units. Now the beauty of this is, and I wrote this little so to just kind of remind you that this is a formula that will always work. X will always be the radius multiplied by the cosine of theta, and y will always be r multiplied by the sine of theta. This is something to memorize. It is so useful, and it's especially going to be useful when we want to know the slope. Because if I give you some kind of function in polar coordinates and I say, what's the slope, meaning what's dy dx, then we need to know, in terms of y and x, what that polar curve is like. Okay? So I'm going to just do one more. I don't think we need to do all 4 because it's just a very nice formula. Let me just write this down. So we're going to have x is equal to 2 multiplied by the cosine of negative pi over 4. And y is going to be 2 multiplied by the sine of negative pi over 4. Okay, so cosine of pi over 4, negative pi over 4 is square root of 2 over 2. So 2 multiplied by root 2 over 2 is just root 2, square root of 2. 2 times the sine of negative pi over 4, well, the sine of negative pi over 4 is negative square root of 2 over 2. So 2 multiplied by that will be negative square root of 2. And it's just that easy. Again, if you don't remember your trig, like the hand trick or something, you're going to have to look back at that or get some help on that. But the actual formula is pretty easy. So what if we wanted to go the other way? Well, it might actually even be a little bit easier. Let's do this first one. It's 2, negative 2. So over 2, down 2, points right here. If I wanted this in terms of polar coordinates, well, I know this is 2. I know this is 2. What I need now is the angle and the radius. Well, of course, Pythagorean theorem gives me the radius. All I need to do is do 2 squared plus 2 squared, square root that. That'll give me r. And the angle, well, I know two sides. I know the adjacent and opposite. So the tangent of theta is equal to, in my case, 2 over negative 2, I guess. So I just do the inverse tangent to both sides. So again, I wrote myself this little thing so I would remember to give the formula. It's to get r, we usually leave it in terms of Pythagorean theorem like this. And to get theta, we just do the inverse tangent of y divided by x. So 4 plus 4 is 8. Square root of that, I guess you could reduce and have 2 square roots of 2. And the angle would be negative pi over 4, like that. Okay, so it's just those two formulas. So let's do one more. Okay, so r squared would be equal to 2 squared plus negative 4 squared. So r squared is equal to 20. So, of course, r is the square root of 20, or 2 square roots of 5. Okay, and then theta is the inverse tangent of y over x. So the inverse tangent of negative 2. And this is not one you'd necessarily have memorized, so you type that in your calculator, inverse tangent of negative 4 over 2, or negative inverse tangent of, or inverse tangent of negative 2, and you would get negative 1.107 as your angle. Okay, so that's all there is to it. So let's combine these things. We know that x is equal to r cosine theta, y is equal to r sine theta. We know these two rules on this one, that r squared is equal to x squared plus y squared, and theta is equal to the inverse tangent of y over x. And let's convert some equations. Okay, so how would we convert r equals 4 sine theta? I put this one on here because most of them are actually pretty easy to convert. This is one that's tough. And again, you know, you kind of think about these, you know, conversions, and you say, well, I know that r squared is equal to x squared plus y squared. So maybe squaring both sides. It's tempting to do that, or to think, you know, that the square root of x squared plus y squared is equal to 4 sine theta. Something. What if I multiplied both sides by r? So I have r squared equals 4r sine theta. Well, now this is x squared plus y squared, and this is y. Remember, x equals r cosine theta, y equals r sine theta. You really can do all of these types of problems with just these 3 pieces. And again, these are worth memorizing and knowing those 3. Okay. Now, x squared plus y squared minus 4y equals 0. This is the equation of a circle that's been shifted over 2 units. And we'll get to how you graph these things. But I just wanted to show you that they are, in fact, the same. They each would be a circle just with its center at 0 or 2, 0. Okay. Now this other one is maybe a little bit easier because, you know, we know that x is r cosine theta. We know that y is r sine theta. Well, the 9. So we've got 4r squared cosine theta sine theta equals 9. And that's really all you'd have to do. Okay? So the conversions, you really only need to use these 3 things, and you just kind of play. So this first one was polar. We turned it into Cartesian. And this one was, the second one was Cartesian, and we turned it into polar.